All right, so first of all, I want to thank Alex for reminding me that I'm supposed to be here. I was deep in thought preparing for this, and then I saw a message from him and I was like, oh yeah, I need to get on. So thanks, Alex. Um, Secondly, if you guys have any questions or thoughts, please post them in the comments for this video and I will check on that occasionally. Thirdly, thanks to Ian for sending in this question and sending in his design. Spoiler alert, I don't think I'm going to solve all the problems and answer all the questions that Ian has, but hopefully I will just continue his thought process in the design and maybe help him eventually get to some solutions down the line. I see a lot of this as just like conversations. I find a lot of times that I don't have the perfect solution, especially because I am often not in the room with you doing the measurements, but I can help you come up with kind of the next questions to look at. So this one is also great because it involves some geometry. And coming up at the end of this month, I'm teaching a workshop called Practical Guide to Speaker Aim, which is a lot about geometry and how do we plan our designs either when we arrive in the room and we have to start setting up, or maybe the day beforehand when we see the equipment that we have and we see the design and we start thinking about, okay, how am I going to aim this and where am I going to place it for maximum results? So if you're interested in that, I'm going to put a link to it in the comments right now. Oops, I clicked end, cancel. I need to click return. There we go. Cool, so it looks like some people have joined us already. Alex is here. Hi, Alex. Will, Manuel, and Amit, Adenini. Who else is here? Hailton, Anthony. Hi, Anthony. Cool, glad you guys could be here. So let me show you quickly the room we're going to be looking at. It won't let me zoom in. Okay. So here's the room. Notice that this back half is not filled right now. But here's the seating. Here's an image from the back. And you can see this RCF system hanging up here. And you can see these front fills along here and some subs down here. So to Ian's question, I would love any input on the current hang location and splay of the line array. Trying to get both full room coverage versus minimal wall reflections is a battle, especially as we have no room treatment on our sides. Okay. And I've been told the rear treatment is not correctly set up as they are spaced too far apart to be effective. So he's saying he's got some room treatment back here, but none on the sides. So he wants to look at placement and aim and splay of his line array. So he did send me an ease focus file, and unfortunately I wasn't able to open it because apparently I don't have the authorization for the GLL files. I don't really know how that all works. I'm not an expert ease focus user, but he did also send me the PDF report so I could just see where the pieces of the puzzle should go in. So what I decided to do was just make my own design in MapXT so that we could play around with it a little bit and just talk about how I think about this stuff, how I start to think about placement and aim, and also so that you guys can contribute as well. So as I'm talking here, let me know if you do something differently. Let me know what your ideas are, because this will all stay on the Facebook page, and then Ian can watch this later, and then he can look at all of your ideas, and he can take my ideas and your ideas and hopefully come up with some good next steps. So, a couple of things about the design that I have here. First of all, I've got two audience shapes, and that is because another piece of the puzzle is that on a typical Sunday morning, our target audience setup is this size, but then we rent out the space and the target audience gets bigger. Now he says 90 feet deep here, but he also told me that the space was 120 by 120 feet. So the audience can't start at 15 feet and then go another 90 feet. So I made it a little bit shorter, but that's why there are two audience spaces here. I guess one for Sunday morning, and then they rent it out and it gets bigger. So the best option, I'm just realizing here, Ian, would be if you could take your arrays down, redesign them, and put them back up when you have a rental. But I don't know if you can do that. So I'm going to be talking about this as though you need kind of a one-size-fits-all solution, which isn't the best. So that's my first suggestion. Can you reset this stuff? Are they on motors? Can you take them down, change the splay, and aim whenever you have someone come in and do a rental? Because I think that'll be a better efficient use of what you have. So let's talk about, let's look at this horizontal plan view here, looking at it from the top, and let's talk about placement first and then aim. So the first questions that I have when I'm looking at a design and placement and aim is, will it fit? How does this speaker shape, the speaker coverage shape, match the audience shape? And the first thing I'm wondering is, are these speakers so wide that one of them could cover the entire audience? Because that means they could crossfire and you could have a stereo system. And I also know that you're worried about having too much leakage spill onto the wall reflections. So I'm worried about that as well. A quick way that I figure that out is with this calculator that I have called Will It Fit? And I can just quickly put in here depth and width and get a forward aspect ratio and also a coverage angle. And then I can also put in my current coverage angle and see if it fits, and then I can play around here. So I'll be using this at the workshop at the end of the month, and I'll be handing it to those people. This is from Pro Workshop Seeing Sound. It comes in the second module when we start talking about forward aspect ratio. Forward aspect ratio is just defining a speaker's coverage shape by length and width. That's it. And it's really handy because if we can define an audience shape by length and width, then we can basically then just do a puzzle where we match speaker coverage shape by length and width with audience coverage shape by length and width. So that's the first thing that I did here. If we look at this Sunday morning audience, let's make the other one go away for now. If we look at the Sunday morning audience, then it is 55 feet deep, that's from the speaker, and 80 feet wide. That's the whole thing. So if we tried to do that with one speaker, that would be a forward aspect ratio of 0.69, and we don't have any speakers that wide, okay? So what we really need to do is split the width in half, which is the design that they have here. This shouldn't be here. I just have that here for demonstration purposes that I'll show you in a second. If we split the width in half though, then it calls for a 90-degree speaker, which is about perfect for what we have. Okay, so first question answered. I'm not going to do stereo. I'm not going to try and crossfire these. I'm going to take this left speaker and I'm going to say you are assigned to this side, and this right speaker and say you are assigned to this side. Sorry, I did that backwards, right and left. And I just have this center speaker here to demonstrate this first option here, which is one speaker the right shape for this entire audience. And I can just do a quick prediction here to show you that you've got this teal color hitting the back, but then the teal color does not hit the sides. And ideally, we want the same color at the back and the sides to show that we have matching shape. So now that I've demonstrated that to you, I'm going to go ahead and get rid of that. And here's your right side speaker. And we can see that this is a little bit better match for the shape. So now we've got this teal color at the back, and we've got one not quite teal over here on the edge, but pretty close. So not perfect, right? Perfect would be a 93-degree speaker, I guess. But pretty good. Okay, so now in terms of placement, I have a pretty simple method for this, which I'm pretty sure I just got out of Bob McCarthy's book years ago, which is that you want to place at the center of the audience plane. The funny thing about that is that we often want to be in the same position as projection. So as I've been working on more and more corporate events in the last few years, I've noticed that projection also wants to be like, normally you put a screen here and a screen here, and then you put your projector back here if you're doing front side projection. That's exactly where the speakers want to be, but then they get pushed out to the side and then we have to aim in or over here. So just an interesting side note. Okay, so these speakers, where would I place them? I would want them to be as close to the center of the coverage area of this audience as possible. That way I can best match the shape. If I have to move them off to the side, then they're going to kind of aim in, and then we have kind of an asymmetry. Now for audience shapes that aren't squares or rectangles, that might be what you want. But 9 times out of 10, a center position here is really what we want. So if I turn on these center lines, you can see that that's what they already have. So perfect design for this Sunday morning service. Now the complication comes in if we take a look at the rental placement. Oh, by the way, how did I get these? So this is one of the things we're going to be going over. One of the very first basic things. How did I get these center positions of the audience? Well, I could measure from here to here, find the center, measure from here to here. But the fastest way and the most fun way is just to draw a bunch of diagonal lines. So you can see here that I just drew diagonal lines through every rectangle, and that's how I found these centers here, okay? And then I just hid those diagonal lines. So I often have a layer called measure where I can just draw a bunch of lines and make it ugly and then pretty quickly clean it up. So here are the 2 center points of our 2 different, very different sizes of audience. But they're not too far off, luckily. So we would only have to move this over a little bit to get it in the center there. So now's where we can start talking about aim. Aim, again, is very simple. I would often just estimate by aiming through the center of the center. Usually that's because we have the wall right next to the edge of the audience, and overlap onto a wall is no worse or better than overlap into the center of your audience. This other speaker is basically like a wall. If you were to imagine a wall right here and a mirror there, then you could estimate the reflections pretty accurately by just measuring, imagining that this is a mirror and that there's another speaker over here. So, but our wall is farther away, right? So we have a little bit more leeway if we wanted to aim out. So what's interesting for me here is that Ian's worried about wall reflections, but his audience is pretty far away from the wall as far as I'm concerned, especially when you think about it in relationship to the potential danger of just aiming through the middle here into this other speaker's, the overlap just onto another speaker's coverage pattern. So what I'm seeing here, though, is that if we aim for this rental property, then we might aim something more like this, right? And the good thing is that that's not too far away, and our walls are not right at the edge of the audience here. So I think that this is appropriate. And I think as far as the aim goes, Ian, my next step would be for you to decide what's more important here. If you're going to leave these set for one space, do you want it set for the larger space or the smaller space? And I don't know, maybe a little bit of the economics of how, you know, the space works come into play here. You really want to make the rental people happy? Do you really want to make the Sunday people happy? But the next step I would take now is to place 3 microphones at the on-axis and crossover positions, and then adjust your aim that way so that all of those positions match. And I talked about this in one of the previous Q&As, so I think I'm not going to go over it again here because I don't want to make this super long. But that's how you would set the aim in the field if you had that available to you. And you could actually do that here in MapXT as well, or probably in Ease Focus. Put the microphones where you want them to be. So let me just show you that real quick. Actually, maybe let me just show you the results of that, why you want to play with that. So if we look at this as being, let's say, sure, 5.2, and then we'll just mirror that. Negative 5.2. And now if we look at a prediction, we might look at this, and let's look at the rental property. And we might say, hey, if we put 3 microphones through here, if we want a unity line through here, then now it's too loud in the middle. Because we want, ideally, what we want is to have a matching unity line at this position, and this position. So then with our microphones there, we would experiment with aiming them farther out. And we would look at our measurement viewer then of those 3 microphone positions, and we would see that as we maybe aim them farther out, that you have less overlap, and these 3 positions start to equalize, start to get closer to each other. And I know you're worried about those wall reflections, but again, I don't think we're in too much danger here. You notice that we've got 1, 2, 1 color change. So I guess it's a balancing act, right? If you want to have really even coverage here, then I would pursue this route and keep aiming out until all of these positions are the same. If you're really worried about those wall reflections, which I wouldn't be too much, then you would want to keep the aim that you have probably and just accept that you're going to have more overlap in the center. Okay? So let me see if there's any comments in the chat and think about if there's anything else I wanted to say about horizontal aim. So if you're just joining us, I would love for you to chat in with any ideas that you have for Ian. These are just, I'm going through some of my thought processes, but I don't know if this will be the actual result for him. Okay. So Will is telling me that I need to import the speaker definition GLLs from the manufacturer on EaseFocus to be able to open the data. Okay, cool. I'll look into that next time. Thank you, Will. And Eduardo, Marcus, and Cody, thanks for joining us. Okay, so I think that's all I wanted to say about the aim. You asked about the placement. We talked about the center of this, placing near the center of the coverage area. You wanted to know about the aim, and you were thinking aim inwards, but because each of these speakers is kind of assigned to one half of the room, I would actually focus more on aiming them through the center of their coverage areas, where I drew these pluses. And then in the field, I would look at putting microphones across this unity line and trying to make all of those match. And you could even put another microphone over here at the edge, or if you have one microphone, just measure all these different positions. And then you can see the results of the wall reflections as well, since I know you're worried about that. Okay, let's move on because you wanted to take a look at the splay of the array as well. So here is the current splay that you have, and before I even look at anything else, let's just talk about this a little bit. Actually, before I talk about the splay, I want to talk about the number of boxes quickly. So let's actually look at the design. So again, I just decided to put this into mapXT, and let me hide a few things here. So again, I've got your 2 audience planes here. I've got audience 1 and audience 2. And I'm just going to go ahead and look at audience 1 because it seems to me that that's what you have it aimed for right now anyway. Cool. So here's your array. Let me make sure that it currently matches to what you have. So negative 8.8 and then 28815. Negative 8.8, 2, 8, 8. Oh, you might be wondering why I chose leopards, and that's basically just because they're similar height, because I wanted to look at the geometry of this. Over here I saw that your RCF speakers have a height of 294, and these leopards have a height of, where is it? There it is. 282. And I thought that was pretty close, so that's why I'm using those. All right, so I think I've got your design here. Did I get the placement correct? 22 feet in the air. Great. So let me tell you my initial concern here, and I'm going to hide audience plane 1. By the way, why does audience plane 2 start so much farther back? Audience plane 1 also starts that much farther back. I have 2 lines here, you can't see the division. And that's because of this front fill that we didn't talk about yet. This front fill is playing up, and I'm going to assume that because the front fill is so low, by the way, it would be nice if you can get this higher, but I assume that you can't because that'll block sight lines, etc. But I'm assuming that because this front fill is so low, it's only going to play back maybe 2 rows because you're kind of shooting into people's, I don't know, chests and head here. Maybe 3 rows, so that's why I gave your front fill a coverage of 6 feet here, and I'm going to say that your main array starts at 21 feet. And just to make things a little bit less messy, I'm going to get rid of that guy for now. And let's look at the longer audience plane, your rental plane. Okay, initially, some red flags are coming up for me because I'm seeing a pretty far front-to-back distance ratio, and I'm not seeing very many boxes here. Designing for shorter line arrays is definitely more challenging, so it's no wonder that you've been trying to figure out how to improve this and why you reached out to me. This is where I see a larger problem so far than just in the horizontal placement and aim. Here's my reasoning behind that. Let me redraw this line. If we just take a quick look at the front to back distance ratio, I'm just drawing lines here. Let me make sure I have the right one selected. And I draw a line from here to where I'm starting coverage. This line is about 26 feet long. This line is about 96. 96 divided by 26 gives us 3.7. So with the front to back distance ratio of 3.7, I'm expecting to see at least 4 speakers in the top zone to if we're going to do 1 speaker in the bottom zone. So if we're looking at the smallest array possible, we need at least 5 speakers, which is what you have here. The only problem with that is that then these 3 speakers are pretty much dedicated to covering just this back half of the room, and then you've just got 1 speaker that's covering this front half. Now, sorry about all these notifications. I'll turn those off. Okay. The other problem with that I see is if we have a front to back distance ratio of, what did I say? I think 3.7. 3.7 log 10 times 20. Then we're also going to have a volume SPL offset of 11.3 dB. Now some of that will be made up by the fact that we're putting 3 or 4 speakers into our top zone, but that means that we're potentially turning down this bottom box by a lot. Okay, And I would want to ask you, how is the SPL the level distribution here? When you walk from back to front, does it get really loud in the front? Also, do you have control over these bottom boxes? Can you turn a few of them down? Because I think you're going to have to do that no matter what we do with the design here. So the first thing I wish we could do is add more speakers to this array, right? If we could make this array twice as long, then we could have more flexibility in figuring out how many speakers we put per zone. The whole design of the design that I learned, Bob McCarthy's Papa Bear, Mama Bear, Baby Bear situation, and putting boxes per zone based on distance ratio is great. It doesn't work that well when you have really small arrays, I have found. And that's tough because that's where most of us start, right? We don't go into we don't start off by designing these giant 20, 30 box arrays. With smaller arrays, it gets a little bit tricky. Okay, so I said my piece about that, but I doubt that you have more of these boxes to just add on to the bottom here. So let's now look at how you're handling this with display. Let's just talk about the aim first, I guess. So let's go up here and I'll turn off all the center lines except for the bottom and top. And I'm going to hide my measurement layer. Turn on the center line. So at first this might look like you've got it a little bit high, but as we are going to see in a second here, that makes sense. Should I go ahead and do a prediction? Let me not do that. Let's first just make sure that you are covering the entire audience plane. So I'll turn on the center line of the bottom box as well. Cool. So you've got plenty of splay here, probably too much. If you've got that front fill covering the front, couple of rows of the audience, then you shouldn't need to cover all the way to the bottom here, assuming that your front fills go all the way across the front of the audience. Okay, I'm making some assumptions here, so you'll have to adjust this if that's not true. But it looks like your splay is set a little bit too hot here, a little bit too high because you're kind of over covering. The other thing I want to draw your attention to is this. So ideally, we never want to go, we don't want to create these big jumps in our splay, otherwise we're going to have a gap. So I'm going to predict that between boxes 2 and 3, we're going to have a gap because you're jumping up from 2 to 8. Let's look at that real quick. What did I say? Boxes 2 and 3? So I'll turn on the center line for boxes 2 and 3, and we'll look at a prediction at 4K 1/3 octave bandwidth. Okay, there's the gap that I was thinking of. And also, we see that, our first pointy finger of coverage here, the aim of the array is not actually with that top speaker. So this is why that top speaker doesn't aim at the very last row, is because we've got, this thing happening right here. Okay, so I think the next thing I want to look at is just how we can sort of start playing with the splay, because again, I feel like with smaller arrays, it doesn't make a lot of sense to start looking at them in terms of zones. It can be quicker just to start playing around with the splay. So the first thing I want to do is get rid of this gap, because I don't like that. And the next thing I want to look at is getting this aimed a little bit higher so that these people in the last row are getting what they deserve. Okay, so we know that this is a problem. So if we don't want to jump from 2 to 8, then what do we want to jump from? Well, the number that I'm pretty sure will guarantee us no gap is 1.5. So 2 times 1.5 is 3. Did I really need to calculate that? Maybe not. And let's just first see if that fixed our gap. It did. Okay. And we have a little bit smoother coverage here through the top. Now we've got a gap down here, and I bet that's between the bottom two boxes. So let's move the center lines down there and check that out. Yeah, so a little bit of a gap between these two boxes and also between these two boxes. So let's reduce both of those. Again, 3 times 1.5, 4.5. Let's go up to 5. 5 times 1.5 should be 15. Oh no, sorry, 7.5. So let's go down to 8. Okay, and notice that I'm still not way out of the audience plane that I want to be covering here with these bottom two boxes. Cool, so doing better, right? If we want to talk about gaps now, it would be back over here. And let's take care of that aim that I was worried about. And it would be nice to know where this thing is pointed. So I love the fact that you can turn these center lines off and on. Let's see if that's the case. Not quite. Maybe it's this one. There we go. So this line is a little bit closer to that. So I'm just going to rotate this up a little bit. So, uh-oh, is it going to crash? Oops. Let's reset this. Come on, computer. Okay, let's leave it there and see what that looks like. Okay, so I got this thing pointed a little bit too high, but you can see what I'm going for here, right? I'm trying to kind of remove some of the gaps from the design and also make sure that we kind of have even coverage as we move down here. So I don't know how much more time I'm going to spend on this, but let's first just aim this down a little bit. And predict. Cool, that's a little bit better. So now we've got this first lobe here, like aimed right at these guys here. And then we've got a little bit of a gap, and we could work on that. And then the cool thing is that if you look at this, and this is indigo, then we got about 2 color changes. So that to me makes me think like this is going to be okay, because I may have to do some gain shading in the bottom zone, the bottom 2 or 3 boxes, but hopefully not more than 6 dB. Okay, that's my goal. And I feel like if the front to back ratio is less than 6 dB, then it's probably better not to do anything and just leave the array alone. The other thing that's tricky with small arrays I've found optimizing them in these rooms is that a lot of times the gain shading doesn't do anything. So I often try it just to see if it'll help, but a lot of times it doesn't do anything. So Ian, what I would do next after you work on this design and find something that you're happy with is then place microphones at least 3, or do at least 3 positions, more if possible, and do vertical top on axis here in the center, and then vertical bottom, and then try the gain shading. Try turning down these bottom 2 boxes. If you turn them down 6 dB and you don't see any of the traces move, then forget about it. You're not going to have any success. But if turning down these bottom boxes does, in the high end, bring everything together a little bit more, and maybe you walk around and you like how it sounds, then that can work for you. Again, with these smaller arrays, I've found that it is often unsuccessful to do any level changes of the boxes. But I do always like to give it a shot. So I think I'm going to stop playing with this now. I've shown kind of the concepts that I wanted you to think about. Also, these aren't exactly the same speakers that you're using. It would be better to do this in I guess Ease Focus or whatever modeling program is best for RCF speakers. And look at the concepts that we've talked about. Try avoiding those big jumps in splay angles so you don't have gaps, and then keep playing around with it so that you can try to even out the coverage, remove gaps, and that's just kind of an iterative, with these smaller arrays, it doesn't take that long because there's not that many splay angles, but it's just kind of an iterative process of adjusting the splay angles a little bit and then readjusting the aim. But it's fun. So Ian, I hope this has been helpful to you. And if you want to keep talking about this, let's do that in the comments for this video. Again, if you guys have any ideas for Ian, I would be happy for you to help him. And you know what? I can upload these mapXT files into the chat. Let me see if there's anybody else talking that I should see. Philippe says, what about a 3 speakers line? I'm not sure what you mean by that, Philippe. Oh, I mean 3 arrays. You mean horizontally? You could do that. I don't know how that would really help you. I think we've kind of shown that these boxes are wide enough that 2 of them for the entire space is good. I think if anything, if you had more speakers, you would put a delay down here. So if we could shrink the audience plane basically and put, you know, some delay speakers back here, that might also be another solution, Ian, for your Sunday service versus rental situation. Is you've got, maybe you design these for the Sunday service, and then maybe you've got a delay of another pair of these or something that then cover the back half. I don't know. If you had more speakers, probably it would be better just to add them on the bottom of this array and then redesign, you know, take them down and change the display angles for your rental service. Shots says, any word on Map 3D? So my understanding is that Map 3D is coming out in 2020. They did have it at InfoComm and they were showing it off, but no one gets to use it yet except for Meyer Sound employees. Alex says, is your audience plane too high? Maybe. What do you guys use for audience plane? I use 4.5 feet because I think that's average sitting head height, but maybe that's totally wrong. I know what Mauricio does is he uses an average, he uses a box, and I'm not sure what his box height is though, but he would do something like this so that he could look at an average cross-section of human head heights. But I would love for you guys to tell me. I really don't know the answer to that. I look it up every once in a while, but I've been using 4.5 for a while because I'm thinking about ear height seated, and I think I measured my own ears one time. Most people tend to sit during a church service. So yeah, so Alex, that's why I chose 4.5 feet for the height here, because I figured it was for sitting. Cool. I think those are all the comments. You guys, thanks for letting me invade your Facebook for a little while. I like doing these. I'm going to keep trying to do at least one a month. So I'll put the link to submit more questions also in the comments for this video. Anyway, I hope you guys have a great rest of the day. Thank you.